Okay, we can see your screen now. So you can just open your slide, your PowerPoint presentation. Yes, and show slideshow there. Yes, we can see your screen now. Thank you.
Okay. Can you hear me now?
Yes, yes, we
Right?
can hear
Okay.
you. Yeah.
Right. Okay. Sorry for the some delay here. Okay. Right. Okay. Good evening to all. First of all, I'd like to thank Ms. Uraj Shaukat, Chair IEEE WIE, NUST PNEC Student Chapter, for giving me the opportunity to present. And also special thanks to Mr. Gulam E. Mustafa Abro, who introduced me to Ms. Uraj. Okay, today I'll be talking about overview of evolving disruptive technologies. But before that, I was asked to present something on the IEEE student branch activities. Just like to inform you all that I'm an associate professor at the Department of Electrical Engineering at University Technology Petronas. I'm also head of Smart Assistive and Rehabilitative Technology Research Group under the Institute of Health Analytics. And I'm the chair of IEEE Robotics Automation Society of Malaysia chapter, and also counselor for the IEEE UTP student branch. So being the chair of IEEE Robotics and Automation Society, Malaysia chapter, and the counselor of IEEE UTP student branch, basically we work together, the student branch as well as the IEEE RAS Malaysia chapter to organize events. So Ms. Uraj, since today being the IEEE day, she requested if I can share some of our activities relating to IEEE. So therefore, in this talk, I have divided into three parts. Part one, is basically about the activities of IEEE student branch. So if you want to get more information about our student branch, you can go to our link here, shown here. And these are the office bearers for 2020, where we had the election sometime in early of this year before the COVID pandemic set in. And these are some of the activities that we have carried out. So one of them would be International Women's Day in 2019, whereby some of our uh, student branch members were actively involved with the IEEE Society of Malaysia chapter to organize this International Women's Day. And we have also had this IEEE Day for 2019, where we had the cake cutting ceremony, where it was in conjunction with the conference that we organized in 2019. And normally we conduct many activities. One of them, would be like what is shown here is the IEEE Drive Talk, and it was given by myself as well as the head of the IEEE Malaysia section, Associate Professor Dr. Faunizu. And we had latex article writing workshop, which attracted over 50 students, postgraduate students. So it was quite a success for us. So like this, we organize many activities. So if we look at the next one, in 2019, we organized the 17th IEEE Student Conference on Research and Development, which we call it as SCOT. It was a huge success for us because this was organized by the IEEE UTP student branch. And these are some of the photos, the highlights of the conference, whereby, this is the opening ceremony. This is the group photo. And this is where some of the participants visited one of the caves here as part of the social visit. And the other thing that I would like to share is the International Advanced Robotics Competition, IARC, that we have been organizing since 2017. So thus far, we have organized for 3 times. The maiden one was in 2017, followed by 2018. And recently, as of February this year in 2020. So these are some of the pictures. You can see that, students in this, particularly in this competition, students are given a theme, and they are supposed to construct the robots and then carry out the specific tasks given. Obviously, we choose the best team. Okay. Apart from that, this year particularly, we have organized several webinars. So we can see some of these webinars here. And apart from that, these are the activities of IEEE student branch. As I mentioned, since I'm the chair of the IEEE RAS, as well as the counselor, or here counselor means the advisor of the student branch, we work together in organizing events. So IEEE RAS, we also have the website where we have conducted several activities. Okay, in terms of, I'm just giving a screenshot of some of the activities here. It's like the, look at the industry research collaboration, Katia for augmented reality, okay, research colloquiums that we conduct every week, okay, and then final year project showcase, and so on. We have many activities, but basically these activities, I can divide them into drive talk, whereby we carry out drive talks to encourage students to join IEEE society. And then we carry out workshops, short courses, seminars, technical talks. Okay, and then this year, since we can't have face-to-face seminars or workshops, we carry out the webinars, as I showed you earlier. And also, we have carried out conferences scored by IEEE student branch, and then Roma by IEEE RAS. And we do carry out robotics competitions, as I mentioned earlier, the IARC. And we also carry out, what do you call that, as the social activities. One of the activities that's quite prominent is the nurturing young boys, by encouraging them to participate in various games, like probably football, and then microcontroller training, that kind of things. And also, we do participate in events such as the Women's International Day, IEEE Day. All these activities are carried out, for the benefit of the members, especially the students, and to encourage more participation, from the students. And even though, from the IEEE RAS perspective, Malaysia chapter perspective, the number of members are declining, for various reasons. But, it is quite encouraging for us to see that the number of members from the student branches are increasing. Okay, so I think that is something that we would like to focus and drive further. Okay, that is the gist of the activities, in terms of the IEEE student branch as well as the RAS. Now I will move on to the second part of the talk today, which is the title. We're going to look at the disruptive technologies. Okay, even though there are many disruptive technologies, but I would be only focusing on 6 such technologies. Okay, so before we go on to the type of disruptive technologies, let us look at the definition of disruptive technologies. A disruptive technology is one that displaces an established technology and shakes up the industry, or a groundbreaking product that creates a completely a new industry. Okay, and this definition is coined by the Harvard Business School professor Clayton M. Christensen. So some of the disruptive technologies that we can look at is IoT, and then we are looking at AI, okay, autonomous vehicles, 3D printing, medical innovations, and robotics. So now let us look at one by one. So if you talk about Internet of Things, okay, This technology refers to the identifiable objects and virtual representations on the internet. So there is a connectivity between various aspects. So we are looking at equipping all objects with machine-readable identifiers, okay, and minuscule identifying devices that could change lives. Okay, the IoT devices that we are looking at are being increasingly used in healthcare, mining, manufacturing, and others. Okay, obviously, with any new technology, there are also, some what do you call it, disadvantages or limitations. Okay, so we have to look into the uh, high security threats if you're talking about interconnection between devices. Okay, so this is something that it is also being addressed, but it is increasingly being used, and I think that is the way forward. Okay, so let us look at the second thing. This is artificial intelligence. I think this has been talked about by both the presenters before me. So I don't have to go into detail, but we know that it is being increasingly used in many areas, okay, or many sectors. Now, the third one would be autonomous vehicles. So this modern technology, it covers not only cars, but also, vessels, boats, and drones. Okay, it refers to vehicles or drones that could operate and self-drive in many situations using advanced sensors. So recently, we got to know that, even in Singapore, which is our neighboring country, they have tested buses, autonomous buses. Okay, so the advancement is such. So there is a possibility that this can become a way of life a few years from down the road. Now let us look at the fourth one, okay, which is the 3D printing. So if I recall, back in 90s, okay, we had something called a rapid prototyping technology. Okay, this rapid prototyping technology is basically, were used to create either tooling or products by by layering of synthetic materials, from the CAD design. So, but if you look at 3D printing, I would like to relate that to the rapid prototyping technology. But rapid prototyping technology is an expensive technology which was used only in an industrial setting. But with the advent of 3D printing, 3D printing is able to mimic the rapid prototyping technology and able to produce, products that can be designed by even individuals nowadays. It need not be an industrial setting. So this is increasingly being used, and you'll notice that the price of 3D printers are coming down as well. So now let us look at the statistics or the market size for this. So US, Europe, and China are the top three places with the most 3D printer manufacturers in the world. So according to forecast by Forbes, the 3D printing industry will grow by 133% within the next 3 years. That means this was, from taken in 2017, from 9 million to 21 billion in 2020. And you'll notice that currently, due to the pandemic, some of the PPE, like the face shield, is being 3D printed. Even in Malaysia, there was a, even our university, UTP, is involved in this project. So you can see that, 3D printing is really playing an important role in addressing current issues. Now, let us look at the fifth technology here, is the medical innovations. Obviously, this is a big thing. There are many medical innovations in existence, right? But it is increasing, in terms of its area of application. So some of these are genomic directed clinical trials, gene editing, self-repeated DNA testing. Okay, these are things that is already happening. And you know that currently what is happening is in terms of finding a workable vaccine for the pandemic. So I think increasingly medical innovations will play an important role in the health of human being. Okay, and then the last technology that we would like to discuss is robotics. Okay, this is a very exciting technology. Okay, of course, it corresponds with the capable robotics that have enhanced dexterity, sensors, and intelligence. And if you look at this picture here, this is basically an exoskeleton that is being used to help the paraplegics to walk again. Those paraplegics who normally on wheelchairs, are unable to walk, but increasingly exoskeletons are being used as a tool to aid them in walking. It is not a full-fledged system where they walk, like as a normal human beings, but then at least, a few hours in a day, they can use this to train themselves and to move about. Okay. The other technology is also the exoskeleton, but this is more for the upper limb. So we have exoskeleton in terms of the lower limb as well as the upper limb. And increasingly, okay, there are many players in developing this kind of exoskeletons. So currently, if I may say so, there are about 10 active players for exoskeleton development, especially for lower limbs. Okay. Now, now I've come to the third part of our talk today. This is basically the part 3, where I'm going to share with you some of the technologies or some of the research that is being carried out at University Technology Petronas in relation to the robotics technology. Okay. Okay. So I just now I shared with you in terms of the exoskeletons. Okay. So we are looking at rehabilitation robotics. This is what we would like to call it, whereby it's a field of research dedicated to understanding and augmenting rehabilitation through the application of robotic devices. So exoskeleton is one such device. Okay, and then there are issues when we talk about rehabilitation robotics, whereby number one, the this kind of systems should be acceptable by the users. Okay, there is reluctance, maybe because it is not proven. Okay, but it is increasingly is being popularized through clinical applications. And another big issue with rehabilitation robotics is the affordability. Okay, so these items are very costly. So currently exoskeletons are not really bought by individuals to be used in a home setting, but rather it is being put up in clinical setting, and they go to the clinics to get themselves train for few hours a day, something like that. So that's mainly because the individual is unable to afford it, because it runs into thousands of dollars. Okay, and the other thing that we are looking at is that it is dependable. Okay, um, people sometimes are scared. They these are tools to rehabilitate them, not to be dependent on the tool itself. Okay, so eventually they should let go the tools, and then they'll be able to recover on their own. Okay, so that is another issue that they are uh, faced with. Okay, now let's look at the project that's being carried out at UTP. So I will talk about project number one, which we call it multimodal approach for controlling a lower limb exoskeleton. So basically, currently the exoskeletons are being controlled by sensing elements, uh, where the control is given to the operators to switch on and off. But we would like to currently, we would like to come up with a device which can be controlled by the brain signals. So in order to use that, in order to come up with that, we are looking at two modalities. Number one, obviously, EEG comes with different channels, and we also have the FNIRS. This is the functional near infrared spectroscopy. So what we are trying to do here is that, can we merge these two, or rather optimize the localization here, okay, such that localization of the motor cortex, where it controls the limbs, either is lower limb or upper limb. So what is the need for this? Because we wouldn't want to, equip the patients with many electrodes. So we would like to try to optimize the location of the motor cortex, which directly controls the limbs. So for that, instead of using either 21 or 36, like what is shown here, is it possible for us to come up with maybe 9 channels or even 6 channels? Okay, so this is what we are currently doing in terms of trying to locate the optimal locality, or the optimal localization, by hybridizing both these two modalities. Now, uh, once we get these two, in terms of acquisition of the data, okay, we will be able to compare. Okay, so this is what we are looking at in terms of the process, and from there we will be able to optimize the channel. Now you might be wondering, after optimizing, are we going to use the FNIRS? No, not really. So what we'll do is that we will be only using the EEG electrodes as the optimized location. Okay, so even though currently we are researching into both the modalities. Now, once we have got that, okay, now the movement of the limbs is by the muscle signals, which is the electromyography. So we would be using the optimized localization of the EEG and FNIRS in conjunction with EMG to make the particular motion of the exoskeletons. Okay, so that is what we are currently working on. Now, if you notice here, okay, basically we are, as I mentioned, the EEG, the localized or the optimized EEG together with the EMG, which will be able to control the motor, okay? And basically the motor is part of the exoskeleton. So this is one project that is ongoing now. Now, let me move on to the second project. This is the joint torque model development for exoskeleton. So when we say joint torque, okay, now the joint torque estimation model uh, in literature basically is being divided into 3 models: hill-based muscle model, artificial neural networks, or the mathematical model. So the hill-based muscle model is the most uh, mostly used model here. Okay, but we were looking at, is it possible for us to use an alternative method? What about mathematical model? Will it be relevant or not? So we have been investigating this, whereby we were able to look at the first is to look at the signal processing aspects, where we acquire the raw signals, we carry out the appropriate filtering, and we extract the features that is needed, and then we carry out the muscle activation. So for this, can we use the mathematical model? So we looked at about 12 different mathematical models, and then we narrowed down and looked at the 4 mathematical models that is shown here, and we wanted to see whether it is able to achieve the type of accuracy that we are looking at. So we found that between and for that we used the some algorithms, and we looked at in terms of the values, between the estimated joint torque and the actual torque, how good it is. Okay, so and there is obviously there are variations here, and we found that okay, mathematical model MMA4 can be construed as the optimal mathematical model using the PSO and IPSO algorithms. So with this, we believe that we will be able to move away from the hill-based model and more towards mathematical model in order to come up with the control designs. Now let me move on to the third project, which is the development of wearable exoskeleton. So the earlier two projects, we were concentrating more on the lower limb. One is for the brain signal. The other one is to develop a model to control the exo. Now we are looking at development of a wearable exoskeleton for upper limb. Okay, so this is our first version of our development, whereby it is a 1 degree freedom of exoskeleton for upper limb for the movement of the elbow. Okay, so in this development, we have equipped. It comes in two things or two platforms. One is could be the PC or desktop, or the other one would be in terms of the VR box, where we are able to embed the software into our handphones, and the subject is able to follow the games. We have what we call as serious games or interactive serious games, whereby the subject is able to move the limb as per the games that is displayed here. Okay, so the type of serious games are like this, what is shown here. So we have developed these two serious games, whereby the subject is able to interact. Okay, so you might be wondering, what is the need for us to have serious games or interactive games? Because basically, if it is being obviously, when we did the testing here, it is being tested at the laboratory setting by healthy people, but eventually, we would like to equip this. We have to go for clinical trials, which will involve stroke victims. Okay, and as stroke victims are rehabilitated in the clinical setting. They have to go to the hospital, and they will be attended to by a manual therapist who will carry out some limb movements, and this goes on for about an hour or so, and they go home. But if we were to equip the or rather give some kind of technology to the patients, we must make sure that they are not bored, they're excited to carry out certain tasks. If it's a very monotonous, repetitive work, then it's going to bore them. Therefore, we have to come up with some interactive, exciting games, so that they can carry out the therapy sessions. It's like playing a game, but yet at the same time it's therapeutic. Okay, so it's a repetitive movement without making them to get bored. Okay, so that's the reason why we have to develop the interactive serious games to embed it together with the exoskeleton. Okay, with that, I have come to the end of my discussion today. I'll be happy to answer any questions. Thank you. Right. Okay. Okay. Thank you. Okay. So I can stop sharing, right? Yep.
Hello, can you hear me? I'm sorry regarding the connectivity of my internet. That's why I'm not able to convey my talk. Now, as far as my talk is concerned, it's about the bio-inspired algorithm in which we use on-colony optimization, ACO, for the foraging of food concept. Previously, I told this before. And we use the on-colony optimization for the foraging of food concept by using the ants, and we have to optimize our path and to reach the destination states. And in this research, we are using UAVs to optimize the path and reach the designated area, and with the help of Cauchy-Mouton operators. Actually, normally, if we use the ACO, on-colony optimization, we are not able to quite optimize the path planning. But by using some operators with the on-colony optimization, to make them the hybrid algorithm, we can easily optimize the path as compared to the normal MMACO, maximum minimum on-colony optimization. Here are the contents of my research and the talk. The problem statement, I discussed it previously. Now I'm again just giving a brief, just giving a short review to this. The cooperative path planning of multiple UAVs displays in Figure 1. And keep in mind that the 3 UAVs take off from the neighboring nodes or neighboring society, because in Ant Colony we distribute the whole environment in 3 different societies, and every society we have to take the most best suitable ant which can make the path and to fulfill the path planning of our scenario. And by applying 2 different variants of path planning in order to avoid unwanted threats, in addition, some threats from like hills and the mountain hills and the strong wind forces like tornadoes in the designated area or designated route or map. Due to these aforementioned hazards in the airspace, all candidates UAV need to fly robustly and continue its flight to reach the destination in an optimal way. The UAVs, the UAVs are in the autonomous UAVs, and they can guess the environment adaptively and change their route adaptively. Due to this adaptively, moreover, in the given course, all the aircrafts have to keep safe distance between them to escape collision and arrive the target position by implementing the time synchronization. That is most important content. The mission requirement, the major feature is to complete the comparative path planning by using the proposed algorithm under the rough hazardous environment. Now, what is path planning of multiple UAVs? The model of multiple UAVs path planning depend on the cooperative behavior of UAV. And previously, Dr. Vijhan talked about the flock. So it's same like as this. The coordination between UAVs on the model environment is the main concern. And the cooperative path planning, includes the n number of UAVs. You have to maximize the UAVs and to enhance the algorithm, number of UAVs to fulfill the mission requirement without any accident. In this study, we pay our attention on 2 variants, i.e. path planning, time synchronization, safe distance, and air collision avoidance. You may also, or any student may also, use this type of algorithms to do some projects on robotics, on wheel mobile robots, autonomous robots. You can also do this type of research by using these type of robots. Now, what is time synchronization and safe distance? Our main goal is to select arrival synchronized time for multiple UAVs and maintain safe distance between them. First, if we see the designated area is same, so how can we escape from the collision? By taking the distance measure, the time synchronization, as well as we have to be change the altitude of all the UAVs. Like the one UAV is coming to the height, different height. Second is another height, and third is another height. So we can do this by using the height or altitude. Now, the air collision avoidance. The air collision avoidance is one of the major parameters for the path planning of formation control of multiple UAV control, which is termed as an airspace coordination. We need some airspace coordination between them. In this study, we use 3-dimensional airspace along with the supposition that initially, from the takeoff point, all UAVs in the task have the same altitude, but in the end, their altitudes are different. Now, figure two. This is the it's another figure two. Figure two explain the relationship between the nodes, edge, and leg. The nodes are the waypoints between which the UAV moves. Like the UAV one move from one node M to N or A to B, and the one leg is completed when the UAV turn. The next leg is a start, and the turning point tells us what is the leg. So we have to be complete this cooperative path planning by using different legs and different legs. Since our environment is 3D, we can divide into X, Y, Y, Z, and ZX planes to simplify our calculations. Hence, the nodes are in 2D space. These nodes have a dynamic structure, which varies according to the task environment. Now, what is the coordination between the UAVs? To meet with the requirement of the group of UAVs, we introduced two coordinate coefficients that must add in each UAV as a function of its path or route shown in figure 3. Like you have to be seen in the figure 3, there's the 3 UAVs. Every UAVs will fulfill the path planning coordination, time synchronization, safe distance, and air collision avoidance. And we have to be share our UAV1 share their data with UAV2 and UAV2 with UAV3. If we have an n number of UAVs, we can share all the information with the UAV1 to UAVn. Next, what is our algorithm? The algorithm is max min ACO with CM operator. In this unit of the research, we deploy a strategy which is based on maximum minimum on-colony optimization for path planning of multiple UAVs. Furthermore, the above scheme will use Cauchy-Mountain-based operators, i.e. map, compass, and landmark. The three operators in the Cauchy-Mountain, these are the variants of Cauchy-Mountain, which may help the ants to read the destination precisely. The flow diagram of overall scenario is described in figure 4 below. This is the overall flowchart of the algorithm as stated as the ant colony optimization. First, the ants construct their paths, and after that, they will update and limit their pheromone. Actually, when the ants move from the initial position to the destination area or targeted area, it will move by using update their path repeatedly. And we have to also calculate the fitness test and fitness and optimize path. And after that, we have to give given all the UAVs of the three colonies give their candidate path to the Cauchy-Mountain operator, and in the end, the operator will fulfill these three things by applying these three things: landmark, map, concepts, and read as the coordinated target path synchronously. Now, the simulation results. To check the effectiveness of the algorithm, two different case studies are done for the path planning of multiple UAVs. Number one, check the proposed algorithm with classical method under dynamic environment. And number two, the cross-verify the performance of algorithm under dynamic environment along with the wind forces. Furthermore, to avoid the collision in given airspace, a perfect air collision strategy and coordination between UAVs are introduced for both the case studies. The case study 1. In this case study, in order to check the efficiency of the proposed algorithm along with Cauchy-Mountain operators, we take three best ants UAVs that take off from the three different positions. We call it the three different colonies because it's ant colony optimization. So we have to be defined that each position, like the first position in the graph, is shows in 0, 0, and 0, and next is 0, 5, and 0, and the third one is 0, 10, and 0. So best on UAV take off from the three different positions and read at the target point simultaneously. On one hand, each UAV use both algorithms IEO MMACO and MMACO CM to achieve the aerial path robustly. Now, the second view of the diagram is shown in figure B, and the table demonstrates the overall distance covered by all the three colonies by using the UAVs in terms of MMACO CM. And we have to be seen that the UAV3, it means that the colony 3 will fulfill the path by using the shortest distance at about 22.101. And if we compare with the classical MMACO, maximum minimum ant colony optimization, the distance is about 2.5 kilometer is more as compared to MMACO. Next, the case study 2. In this case, to cross-verify the effectiveness of the proposed algorithm under dynamic environment, along with the wind forces, 3 base-on UAVs will perform cooperative path planning under hilly and windy environments. All the UAVs take off from different locations in order to fulfill the path planning requirement in an efficient way. As seen in the figure C, in the figure 6, the view of cooperative path planning under the dynamic environment, we saw some ellipsoid, and ellipsoid means in this there, it's like the wind disturbance in the simulations, and all the 3 UAVs will fulfill the scenario and escape from the windy environment and to reach at the targeted area. The flight distance comparison of our design algorithm, different takeoff point to the designated area, in which we have to be seen that the UAV2, it means that the colony 2 UAV fulfill the designated, fulfill the path planning scenario by using the shortest distance. But our main motive is not to fulfill to get the optimized path. Actually, every colony or every sub colony is divided into 3 different locations. That's why and in the middle of the map or the graph, there's some windy environment, and hills are also in the path. So that's why the ants or the UAVs must escape from them and to fulfill the path planning organization successfully. To conclude, the study introduced a novel hybrid bio-based inspired algorithm for cooperative path planning of multiple UAVs. The algorithm is MMACO, is combination with CM operators. The proposed algorithm introduced optimal 3D route for path planning of multiple UAVs compared with MMACO algorithm. The results demonstrated that proposed that have a better robustness and eliminated noises and disturbance in the route. The simulation results showed that the proposed method indicates optimal routes with shorter distance, and the coverage rate is quicker than the classical MMACU method as well. It also avoids the collision between the UAVs. And I'm thankful to you to deliver my talk in this platform, and thankful to Uruj and Mustafa Abro. Thank you. And if you have any question regarding this presentation, you may ask on my email address. Thank you.
The floor for the conversation. If you have any question regarding any of our guest speakers, you may ask.
Yes, I'm reading the question of Ahmed Sabri. Can I use the on-colony optimization in my project fiber optic sensor to improve SNR in this technology consideration under machine learning? Can you help me? Yes, I will definitely help you if you will share your project introduction or abstract with me, and after calculating this, because I am in Pakistan and not in China due to COVID, and I will definitely help you how to minimize it and how to improve the SNR, the signal to noise ratio. No problem.
Okay, so thank you everyone for joining this event. Ms. Rouge is one of the active volunteer out there in Pakistan Navy Engineering College, National University of Science and Technology, Karachi, and she had been a very wonderful student of mine when I was lecturer over there. I conducted so many workshops over there, and it's a matter of honor for me that I requested my supervisor, Dr. Vijay, my mentors, Dr. Zain Anwar Ali and Dr. Aravan, and including last but not the least, Madam Nurliza, to come up with their research interest and research-oriented topics for this specific day of IEEE. We used to celebrate it with same zeal every year. So now I just want to what we say, thank to all the speakers, because they all are my mentors, starting from Dr. Vijant, who is my supervisor of my PhD studies, Dr. Zain Anwar Ali, he was my master's supervisor and now he is my field supervisor. Madam Noorliza and Dr. Rav, and you people are very great, and you have been guiding me a lot. And this particular, event was just to build a bridge in between all the globe. It's a fact that due to COVID we are separated apart, but this IEEE has united us through this virtual webinars and workshops and virtual meetups. So I, again, thank from the core of my heart that you provided your valuable time for this particular event. Now I just want to request all the participants and the speakers to just turn on their camera so that we may capture this beautiful moment for our formal records, and also for the IEEE Day website. Uh, I request all the participants if they just turn on their camera. Usman, are you there? Usman, Miss Sobia, Sarvijant, are you there? Let me just request Sarvijant. Perhaps he would be busy.
I think all the students also can switch on video camera. Uroj, Neharika.
Okay, so maybe Sir Vijant is somehow, not attending the call, perhaps. So I would like to request the host to go for the multiple screenshots for this beautiful frame. We have so many, beautiful faces, and okay. So thank you so much for joining the event and making a hit of it. And hopefully we are also organizing IEEE Day, the UTP student branch, in which we have invited one of the speakers from MIT US, and soon we will also publicize the event on social media. So we will be delighted to see you also in that virtual webinar for IEEE Day 2020 on 12th and 13th October. Thank you so much. Thank you once again for all participants and speakers. Thank you so much. Oh, sir arrived. Hello, sir. So your audio, your microphone is mute.
All right, okay. Sorry, I was in another
Okay,
MST meeting and I came here. Okay, I thought it's
okay,
all over. All right, thank you very much. Okay, bye.
Okay, thank you so much.
We take one more snapshot now. Dr. Vijan is here. Yeah, we take one more snapshot.
Yes, we can.
Who's taking the snapshot?
Me, I have taken, madam.
Okay, all right. Thank you. Thank you very much.
Thank you.
Thank you. I'm thankful to you.
Okay, thank you. Thank you very much.
Thank you. And one last thing, if anybody who wants to apply for the master's scholarship in China, I'm welcome to apply because the session of CSC will start in November. So if anybody from Pakistan, Malaysia who want to pursue their master's or PhD from Beijing Normal University, China, I welcome the candidate. Thank you from my side.
Okay, thank you.
Thank you.